All right, let's take a look at problems involving finding the area of composite shapes. So here's an example that was on a recent MCAS test. You notice when you look at it, it's not one of the shapes that we have an area formula for. It's not, that's on our reference sheet. It's not a rectangle, not a square, not a triangle, not a trapezoid, not a circle. It's something else. And so any problems like this, what you want to do is try to make the problem a problem that you can solve. In this case, what that would mean is taking your shape that you have and that you can't work with and cutting it into shapes that you can work with. And there's not necessarily one right way to do that. So for example, here we could draw a line to cut this into two rectangles, 1 and 2, just like that. But if we wanted to, we could just as easily cut it across this way. And it really shouldn't make a difference at the end. It's just a matter of what's going to be easier to work with and easier to find the dimensions of. All right, so now that I've done this, the next step is to look at it and think, all right, what shapes do I have now that I've cut it up? Are they shapes I can work with? So I have, it looks like, two rectangles. I labeled them 1 and 2 just to keep track of them. Now we have area formulas for these. Area of a rectangle equals base times height. So our next step is to make sure we have a base and a height for each one. So I'm going to start with rectangle number 1. So rectangle number 1 up here, you look for the base or the length, and you can see that it's 120. And the height, you can see, is when it's drawn this way, is labeled 40. Right? That's how long that line is. So for number 1, we know that the area equals 120 times 40. Calculating that out gets us an area equal to 4,800. All right, so we're starting from our formula and plugging in the values that we found. So change the color here. So rectangle number 2, we can do the same thing. So we know it's a rectangle, so we know what our formula is going to be. That means we need a base and a height. Well, in this case, the base, 90, is easy enough to find. It's labeled. From here to here is 90 feet. But the height, which is stretching from here to here, isn't labeled. So we have to do some additional puzzling out. Right? We know that the whole length of this left-hand side of the figure is 85. And we can look over on the other side and see that going down to this point is 40. So we know that if the whole thing's 85, you know that if you take away the 40, you're left with just this section that I've colored in green, which is 45 feet. All right, so now we know that the height is 45 feet, and we can plug that back into the formula and get 90 times 45, which, and I don't have a calculator up, but it's, I believe, 4,050. And I should label both these feet squared. Remember, whenever you're working with area, you're working in square feet. You sometimes say feet squared. Remember, that doesn't mean that you're squaring any numbers. It's just that our definition of area says an area is in square units. All right, here's another example from the MCAS. And again, this is another one that can be solved by cutting the problem into rectangles. just going to change the color of this. So now here you have some choices. There's not necessarily one right way, but one possible choice is cut off that rectangle there. That square there. Sorry, that rectangle there. And work with these individual pieces. So we now have 1, 2, 3, 4 different rectangles that we would find the area of. See if you can try this one on your own. All right, so here we're left with another one, but we can see it's a little bit different than the ones we've worked with before. In that, as you look at it, there's no way to just cut this into rectangles, but we do have some options. So I'm just gonna, make a choice and see if it works. I'm gonna cut it this way. And there might be other options, there might be better options. All right, we're back. There might be other options, there might be better options, but we're gonna try this one out for now, just to see how it goes. So again, in this case, I've got a rectangle up here, and I've got another shape down here. So first of all, we can find the area of this rectangle. So shape 1, our formula is area equals base times height because it's a rectangle. My base is all the way across 60, and my height is this 20. 60 times 20, and 60 times 20 equals 1,200. And again, in this case, we're working with square yards. Now our other shape, we have a couple things to look for. One is we need to recognize what shape it is. And if you recognize it as a trapezoid, 2 parallel sides here, and a height running between them, which doesn't need to be a side, but in this case it is, then we know we can look to our reference sheet, and we do have a formula for it. 1/2 height, base 1 plus base 2. However, if you didn't recognize that shape, if you weren't sure of it, you could optionally cut it up this way as well, and see if it's possible to find the area of this rectangle 2 and this triangle 3. And it would work. It's another option. However, we're just going to ignore that for now. All right, so we need our different dimensions for this trapezoid. First off, we need the height, which is going to be this line right here. Again, it's not labeled, but we know it's 40 all the way up and down, and we know this other side is 20. And so 40 minus 20 gets us 20. We need our 2 bases. One of them, right here, is that 20. And the other one, this line up here, that's not labeled, but we know it's 60 all the way across, 30 for this section, and so 60 minus 30 gets us 30. 30. And we can calculate this out using order of operations or a calculator with parentheses, depending on what you have available. We can calculate that out and get an answer. And again, I'm going to leave that for you to do on your own. Some real quick problems that you might run into the homework as well. This is treated as a composite shape, and it is. It can be treated like a composite of a square and a triangle. But in this case, we do also have a formula. This is also its own kind of shape that we do have a formula for in our reference sheet. This, however, we don't, so we'd still need to be able to cut it up into shapes that we can work with. So I would start from here and use sort of our guides that are already in place. We have a triangle, another triangle down there, and sort of putting it all together, we've also got this square. So this triangle here, which is 2 by 2, we use our formula for a triangle, 1/2 base times height, which is in this case 1/2 of 2 times 2, which equals 2. For this square, that's a 2 by 2 square, so the area is 4. This triangle down here, following your formula, you will get that the area is 6. And then finally, the area of this triangle, the base isn't obvious, but we know that from here to here is 2. If we look down, we can see that from here to here is another 2, and then it's labeled the rest of the way as 6, which makes it 2 plus 2 plus 6, or 10 all the way across, 4 up, and following our formula, that gets us an area of